So far, we have defined exponents x to the m for all integers. Our definition varied depending on if m is positive, negative, or 0. And we saw the power rule, which said that x to the m times x to the n equals x to the m plus n. We will use these to understand repeated exponents. For example, say we want to simplify x squared to the third power. To do this, let's use our definition of an exponent that says raising to the third power means we multiply something by itself 3 times. In this case, we are multiplying x squared by itself 3 times. So we have x squared times x squared times x squared. But we can rewrite x squared as x times x. So our x squared times x squared times x squared becomes x times x times x times x times x times x. But here we have x multiplied by itself 6 times. So we have x to the 6th. But there's another way we could have simplified this. We also could have simplified this using our power rule. X squared to the third, by definition, is x squared times x squared times x squared. But now, since we're multiplying different powers of x, we can add the exponents. So x squared times x squared times x squared is x to the 2 plus 2 plus 2, where we add 2 to itself 3 times. But adding 2 to itself 3 times is the same as multiplying by 3. So this is x to the 2 times 3, which again is x to the 6th. Simplifying with our definition is more basic and easier to understand, but looking at it the second way helps us learn a new power rule. For any integers m and n, if we have x to the m, then raised to the n power, this is x to the m times x to the m times x to the m n times. But using the power rule, this means we have x to the m plus m plus m n times. But if we add m to itself n times, then we have x to the m times n. This leaves us with the result x to the m to the n equals x to the m times n.